So now we're ready to work our first example of a proof. Now, what is a proof? A proof is when you take a deductive argument that is valid and you prove that it is by showing that you can go from the premise to the conclusion using the traditional square of opposition and conversion, obversion, and contraposition together to work that. So just like in mathematics, when you want to prove that a particular thing is actually the case, we're really just showing our work. How do we turn the premise into the conclusion? So the first thing we want to do is select letters to represent the terms. So we've got all, are. Then we've got inappropriate remarks and faux pas. Then we've got therefore to show where our conclusion is. Remember those conclusion indicators. And we've got some are not. Some faux pas are not appropriate remarks. Now, one thing that we have to look for, and it's shown immediately in this first example, is that not only will you use term complements when you are performing obversion and contraposition, but you also have to look for them when you are translating an argument in order to prove it. So we can see here that faux pas and faux pas are exactly the same. So let's just use an F to represent those terms. But you can see here that inappropriate remarks and appropriate remarks are not identical terms. So that's an indication or a little flag that says that they are term complements. And you can see that the regular one, as we'll call it, will be appropriate remarks. And the term complement, the non, will be inappropriate or not appropriate or non-appropriate remarks. So let's use A for appropriate remarks and non-A for remarks that are not appropriate or inappropriate remarks. So what do we have in the end? We have all non-A are F. Instead of therefore, we're going to now draw a big equal sign and say this is important. This is something that it is necessary to draw. Otherwise, I will not be able to read your proofs. Therefore, some F are not A. So far, so good. What we've got is a definite premise, a definite conclusion. They'll be pretty obvious with proofs. You'll see therefore. We're dividing them by this big equal sign, and we have used letters to represent our terms, paying close attention to any term complements. So now what do we do? This is the point in a proof when students just sort of throw up their hands and say, I just don't know what to do next. Here's what you do. First, you want to rewrite the premise. All non-A are F. Because remember long ago, we talked about how we always begin evaluating arguments by assuming that the premise is true. Well, that's exactly what we're going to do here. What we're going to do here, we're going to assume that it's true, or a more accurate way to put this is that it's given. Then it might also be helpful to just think about what type of statements we're dealing with. So let's go ahead and mark this as an A statement, this premise, and we'll mark our conclusion as an O statement, again, because it's all are, and an O statement because it's some are not. But now what do? Well, we do what I suggested you remember earlier, which is go to the square. Go to the square first. Even though you'll see that there are other ways to work proofs that are entirely correct, and some of them are in the back of your book, what I'm going to teach you is best practice. In other words, what's going to get you the correct answer all of the time by using this strategy. So we're always going to go to the square of opposition first. Let's go there now. We're going to draw the square of opposition, a smaller version of it, A, E, I, and O, and we're going to fill it out just like we did before. But how do I know what statement to start with, and how do I know its truth value? Well, I know which statement to start with because I'm going to start with my premise. I'm going to assume that it's true. And this is extremely important. We will only work with the premise. We will never work with the conclusion. You can think of the conclusion, the best way to describe it that I've come up with is this. When you're working a puzzle, right, like a jigsaw puzzle, all of the pieces are in the box when you start. And the only way that you know what the puzzle is supposed to look like when you're done is the image on the front of the box. But you're not going to actually use the box as a puzzle piece, right? You're going to use it as a reference. So here, the premise is the puzzle pieces, or the group of puzzle pieces, and the conclusion is the top of the box that you're trying to get to. So you're never going to work with the conclusion. You're just going to continue to use it as a reference so that we change the premise until it looks like the conclusion. But the traditional square of opposition, anything that we do with conversion, obversion, and contraposition, all of those things will be solely to do with the premise. We will not touch the conclusion other than to look at it like you would look at a box top on a puzzle. So how do I know what the first one is, what the first truth value is? Well, I know it's going to be the truth value associated with my premise. And because, as we'll see in other examples later on, it does not have a false in front of it, then its truth value is true. It's just a common practice or a traditional practice not to write T in front of true, but only to indicate when it's false. So we know that we can start off on our traditional square with a true A statement. I'm going to do this quickly because I know that you can go back to the video about the traditional square of opposition. So I'm going to use the contradictory relationship between A and O to show that A is false. I know that subalternation says that falsity flows upward to E. And I know that the contradictory relationship says that I has to be true if E is false. So now I've got all of my truth values. What do I do with them? Well, I want to get as close as I can to this conclusion. That's the top of my puzzle box. It doesn't have a false in front of it. So guess what? I don't want to use anything that's false because then I'm just going to make my proof false. So my choices then become, do I use the A statement? Well, probably don't want to use the A statement because I'm already there. All non-A or F is my premise. So what I want to do is go to I. If you want to think it out a different way, and not just by eliminating the things that you don't want to use, you can think about it this way. The I statement is you can't go directly to the O statement that you need, right? It would be great, and sometimes you will be able to do this, if you could just go straight to the O statement, no problem. But if you went there, you'd have the wrong truth value. You'd make it false, and the conclusion is true. It has no F in front of it, therefore it's true. So you want to go to the other particular statement, because once you're done with the square, you will be able to move on to obversion, conversion, and contraposition. That's one of the reasons that I teach it this way, because if you work the square properly, you will be able to do a couple of things. You'll be able to get the correct truth value, and you'll be able to move on between universals and particulars. If you've noticed, conversion, obversion, and contraposition does not allow you to move between the universal categorical propositions and the particular categorical propositions. It only allows you to move within them. So those are the two things you can do with the traditional square. So what I mean by we're going to go to the I statement is that we're going to rewrite our premise on the next line because we're showing our work, we're showing the intermediate steps. We're going to leave our subject term and our predicate term alone, and we're going to change the standard form around it from an A statement to an I statement. So an I statement is some are, and we're going to leave non-A alone and F alone. Now, how did I get from here to here? From this A statement, oops, to this I statement, the relationship that governs A and I on the square is subalternation, so that will be my reason. Now, I'm getting closer. I've got some R and I've got the right letters, but it doesn't look like my conclusion yet. So I have some more work to do. But I can be assured that my work will, if I've used the square properly, that my work will only involve using some combination of, and you don't have to use all of them. You might use one, you might use two, there might be one that you hardly ever use, etc. But I want to pick out the right tool, conversion, obversion, or contraposition to use. So what have I got to do? Well, I've got to get this F over here, and I've got to get this R to be R naught, and I've got to get this non-A to be A. So let's try simply conversion. Let's just switch the places of the subject and predicate terms. That gets us part of the way there, because now my non-A is in the predicate position so that I can do what? So that I can use obversion, the only one that will allow me to go between R and R naught, without disturbing my subject term. So if I performed obversion, it would be sum, it would change the sum to some R naught. It would leave the subject term F alone, and it would change the predicate term only, non-A, to A. Now, it is true that some F are not A. Does that look exactly like our conclusion? Yes, it does. So the proof is complete. We've shown that we can take the premise, work with it using the traditional square of opposition, conversion, obversion, and contraposition, and show that we can turn it into the conclusion. Also, you may be wondering if this conclusion is true here, why is it false on the square? Again, it's because we're not working with the conclusion. We're only working with the premise. So this square is not for the entire argument, it's only for the premise. So that's why the O can be false on the square and the conclusion can remain true. We'll do more videos giving information about proofs later, but this is the first example of a proof.